Welcome to the DIY Honda Garage channel. The DTC code B12D4 signifies a starter request output circuit malfunction in the Honda Accord from the years 2017 to 2023. This specific error is pivotal as it affects the power control unit, PCM, and its interaction with the body's control module. The PCM is responsible for controlling and monitoring various functions related to engine management, including the activation of the starter. When this error is flagged, it typically indicates a problem within the starter input circuit, potentially due to faulty wiring or an issue with the body control module. Understanding this DTC is crucial for addressing starting issues, as it often directly relates to engine cranking behavior and overall vehicle performance. DTC B12D4 indicates a malfunction specifically within the starter request output circuit. This malfunction is tied to the operations of the power control unit, PCM, which is located within the engine compartment and coordinates the vehicle's engine management system. The body control module, which also plays a role in this circuit, is generally situated under the dashboard or within the vehicle's interior. These components work together during the engine start procedure, ensuring that the starter motor receives the necessary signals for activation. If there's an issue with this circuit, it disrupts the communication between these modules, leading to potential starting failures or engine performance issues. Correct diagnosis and repair are vital to restore normal function and ensure reliable engine ignition. The possible causes for the DTC B12D4 include several electrical issues. A shorted wire to power can occur if there's a breach in the insulation, causing an unintended connection to the power source. This misstep can lead to excessive current in the circuit, which the system cannot handle. Another potential issue is a shorted wire to ground, indicating that there's an unwanted connection to the ground reference that could disrupt electrical signaling. Additionally, a faulty body control module may result in incorrect readings or commands, preventing proper communication with the PCM. Each of these issues must be thoroughly evaluated during the diagnostic process to ensure a comprehensive understanding of the problem at hand. When dealing with DTC B12D4, symptoms primarily include difficulties with engine starting. Vehicle owners may experience a total failure to start, where the engine does not crank at all. Alternatively, there could be intermittent starting issues. The vehicle may start sometimes, but fail at other times, which can exacerbate the frustration of the driver. Additionally, dashboard warning lights may illuminate as the vehicle attempts to communicate diagnostic information regarding the malfunction. Recognizing these symptoms is crucial for timely troubleshooting and repair, as they can lead to broader issues if not addressed promptly. Understanding these signs helps in narrowing down the root cause during the diagnostic process. In the first troubleshooting step for DTC B12D4, you begin by clearing the diagnostic trouble codes using the HDS, which stands for Honda Diagnostic System. This tool is essential for resetting the vehicle's error notifications and allowing for a fresh evaluation of its current state. Following the clearing process, perform the engine starting procedure 5 times consecutively. This repeated attempt serves to recreate any conditions under which the error might arise. After these attempts, you'll use the HDS once more to check if DTC B12D4 reappears. If the DTC is indicated again, it confirms that there is indeed a persistent issue that needs addressing. If not, you may be dealing with an intermittent failure, which suggests that the vehicle's system is functioning correctly at that moment, warranting a further inspection for loose or poor connections. For the second troubleshooting step, start by ensuring the vehicle is turned to the off or lock mode. This step is crucial as it prevents any accidental operations while performing checks. Next, utilize the HDS to jump the SCS line, which stands for the Serial Communication System line, and wait for more than 1 minute. This action prepares the system for further diagnostics by allowing it to reset and stabilize its readings. After the waiting period, proceed to disconnect the essential connectors, specifically the PCM connector A, which has 50 pins, and the body control module connector C, with 66 pins. This disconnection is necessary to isolate the circuit and accurately measure voltage levels in subsequent steps. Maintaining a systematic approach in this phase is critical to ensure correct voltage assessments in the subsequent checks. In the third troubleshooting step, with the vehicle still in the off or lock mode, your primary task is to check for continuity between two specified test points. Continuity testing is essential to ensure that electrical signals can pass through the circuit without interruption. Disconnect the previously mentioned connectors, ensuring that PCM connector A and body control module connector C remain disconnected during this testing to avoid misleading results. Specifically, you will be checking continuity between the PCM connector A, number 28, and body ground. If continuity exists, that suggests there is a short to ground within the wire that needs to be repaired. Conversely, if there's no continuity, this indicates that the STS wire is not shorted to ground, allowing you to progress to the next troubleshooting step. The fourth troubleshooting step involves reconnecting the body control module connector C. This reconnection is crucial for allowing controlled voltage measurements in the next part of the diagnostic process. With the vehicle still at the off or lock mode, you will measure the voltage between two test points: the body control module connector C, number 51, and body ground. This testing condition allows you to assess the voltage levels that are being passed through the system. A measurement of 4.37 volts or higher indicates that the body control module is functioning correctly and not contributing to the malfunction. However, if the voltage falls below this threshold, it signals a potential issue with the body control module, prompting the recommendation for a replacement. In the final troubleshooting step, start by pressing the brake pedal while continuously pushing the engine start-stop button. This action activates the vehicle's ignition system and prepares it for voltage measurement. Ensure that the vehicle remains in the off or lock mode during this testing procedure for accurate readings. You will evaluate the voltage between test points, specifically the body control module connector, C number 51, and body ground. This step is critical, as it assesses how the body control module responds under load when the start-stop button is engaged. If the measured voltage varies from 1.72 volts or less, it indicates a fault requiring the replacement of the PCM. Conversely, if the voltage remains steady, a replacement of the body control module is warranted, as that component is likely failing to perform its function. After completing the necessary repairs based on the preceding troubleshooting steps, it is essential to carry out a final repair verification. This step typically involves taking the vehicle on a test drive to ensure that it operates smoothly without any recurrence of DTC B12D4. Monitoring the engine's startup performance during this drive will confirm that the issue has been effectively resolved. Additionally, you should perform a final check using the HDS to verify that no new DTCs have appeared and that all systems function correctly. Proper verification ensures that the problem has not only been addressed, but also that the repairs hold up during normal operating conditions. This step is vital in establishing the reliability of the repairs made and ensuring that the vehicle performance meets the owner's expectations. To prevent issues like DTC B12D4 from arising in the future, implementing a regular maintenance schedule for the vehicle's electrical system is essential. Periodic inspections of the wiring system and connectors can help identify any wear or potential points of failure before they escalate into severe issues. Regularly maintaining battery health is equally critical, as a weak battery can lead to electrical problems, affecting various modules and the starting system. Proper care of these components can prevent many electrically related malfunctions, promoting vehicle longevity and reliable performance. Just as important as resolving issues is anticipating them, and consistent preventive maintenance practices can significantly reduce the likelihood of encountering similar DTCs in the future. In conclusion, understanding DTC B12D4 is crucial for effectively diagnosing and resolving starter request output circuit malfunctions in Honda Accord models from 2017 to 2023. Following the structured diagnostic steps ensures a thorough examination of the vehicle systems and helps pinpoint the exact cause of the issue. By actively monitoring symptoms and employing the troubleshooting techniques outlined, vehicle owners can restore functionality and avoid prolonged inconveniences. Moreover, committing to regular preventive maintenance will fortify the electrical system against similar uncertainties in the future. The combination of effective diagnosis, repair, and routine maintenance is fundamental to maintaining optimal vehicle performance and ensuring a reliable driving experience. Please like and subscribe to the channel. See you next time.